Hello, my name is Arya Pruma and welcome to today's webinar. So we're just going to give a few moments for people to join, so please hold by while we wait for people to join this webinar. So hello, my name is Arya Pruma and welcome to today's webinar. So today I will be going over how to solve linear equations with fractions, and we will be going over a few variations of these kinds of problems. So keep in mind that this session will be recorded and will be posted to our website shortly after this webinar, and the link to our website will be posted in the chat and is also displayed on the screen that you are seeing right now. So with this, let's get started with our very first question. All right, so the very first question we're going to be doing today in today's session is 3 over 5 times 1 plus p is equal to 21 over 20. So before going about solving these kinds of problems, the very first thing you need to be familiarized with is what the LCD is. So just to refresh your memories, the LCD stands for lowest common denominator. So I'll just write that out. So LCD basically stands for lowest common denominator. And to refresh your memories of what the lowest common denominator is, it is basically the smallest multiple of the numbers in the denominator. So I'll just give you a few examples to refresh your memories. So for example, if you had the fractions 2 over 3 and 4 over 6, as you can see, the denominators of these fractions are 3 and 6. So when we find the LCD of these two fractions, we need to take a look at what we have in the denominators, and we need to figure out the smallest possible multiple of the numbers in the denominator. So in other words, in this case, the smallest possible multiple of 3 and 6, which are the numbers in the denominator. So the smallest possible multiples of 3 and 6 are 6. So therefore, the LCD, or lowest common denominator, is 6. So great, now that we have that established, let's go back to our original question here. So our original question is 3 over 5 times 1 plus p is equal to 21 over 20. So as you can see, there is a 5 and 20 in the denominator of the fractions present in this equation. So there's a 5 and 20 located in the denominators. So what you want to do is your very first step is to find the LCD of the fractions in this equation. So let's take a look at the fractions. First one is 3 over 5, and the second one is 21 over 20. So keep in mind, we want to find the LCD, which is the lowest common denominator, which also could be the smallest possible multiple of the numbers in the denominator. So the smallest possible multiple of the numbers in the denominator is 20. So therefore the LCD is 20, and as you can see, 20 divided by 5 is 4, and 20 divided by 20 is also 1. So they provide you with a whole number quotient when you divide the LCD by the denominator. So great, now that we've got the LCD, your next step is to multiply each term in this equation by the LCD. So the LCD in this case is 20, and you want to multiply each term in the equation by 20. So just to refresh your memories, I'm just going to quickly go over what a term is. What separates terms are basically plus or minus signs, so subtraction or addition signs is what separates terms from each other. So if you look at the left side of this equation in our question, we have 3 over 5 times 1 plus p. So as you can see, this is only really one term, as there is no plus or minus sign separating terms in any way. For example, if you had 2x plus 3. 2x and 3 are two separate terms, as there is a plus sign separating these two terms. So, however, if you take a look at the left side of this question, there basically is only one term, as there's no plus or minus sign separating terms. So, as I mentioned previously, what you want to do is multiply each term by the LCD. So, multiplying each term by the LCD. So as you can see, we only had one term on the left side, which is just 3 over 5 times 1 plus p, as there is no plus or minus sign separating terms in any way. So we just multiplied the left side by 20. So next, looking at the right side of our equation, we have 21 over 20, and there's really one term here. It's only really one term, as there's no other terms which are being separated by plus or minus signs. So 21 over 20 is our only term here. So we're going to be multiplying 21 over 20 by 20. So essentially, we're doing this to get rid of the fractions in this linear equation so we can make a linear equation without fractions in order to make it easier to solve in the future steps. So what we want to do next is we want to just write what we have out. And we want to reduce the 20, which is the LCD, with each denominator. So what I mean by reduce the LCD 20 with each denominator is you have multiplied 20 with each term. So basically all you want to do is you can cancel out the number you multiplied, 20, as well as the denominators. So 20 over 5 is 4. So we just canceled them out, 20 divided by 5, and we got a quotient of 4. So we're just going to be writing that on top of the 20. And looking at the right side, we had 21 over 20 times 20. And 20 over 20 is 20, so we just canceled those out. So we just reduced 20 with each denominator. So that's essentially all we had to do for this step. And now we just have to write out what we have. So we had 3 times 4 as we reduced 20 with each denominator. We said 20 over 5 is 4. And we're just going to simply write that 3 times 4 times 1 plus p equals 21. So essentially just writing what we got in our previous step here. So now that we've established this, what we need to do next is we need to just further simplify. So as you can see, looking at the left side of this equation, we have 3 times 4 times 1 plus p. So multiplying 3 and 4, as we can multiply those, 3 and 4, 3 times 4 is 12 times 1 plus p equal to 21, as that's all we have on our right side of our equation at the moment. So looking at this, 12 times 1 plus p equals 21, what we have here on the left side of our equation is what we call distributive property. So just to refresh your memories, if you don't already know what distributive property is distributive property is basically when there is a term on the outside of brackets, of a set of brackets, and on the inside of those brackets, there is 2 or more terms present on the inside. So what you want to do is you want to take the term on the outside and multiply it with each term on the inside of the brackets. So I'm just going to give you an example, another example of what distributive property is. So for example, if you had 2 times x plus 1, as you can see here, you have 2 as being the term on the outside of the brackets, and you have x and 1 as being the terms on the inside of the brackets. So what you want to do is you want to take the term on the outside and multiply it with each term on the inside of the brackets. So basically 2 times x plus 2 times 1. So what we have here is 2 times x is 2x, and 2 times 1 is 2. So when applying the distributive property in this case, the answer would be 2x plus 2. So now that we have that, what we can do is go back to our original question and what we've arrived to so far. So we have 12 times 1 plus p on the left side of the bracket. So as you can see, this is also distributive property, as there is a term on the outside of the brackets and there is two terms on the inside of the brackets. So remember, what separates terms are plus or minus signs. So basically, we're going to take 12, which is the term on the outside, and multiply it with each term on the inside of the bracket. So we're going to do, in the next step, 12 times 1, which is just 12, plus 12 times p, which is 12p. And we're just going to write equals 21, as that's all we have on the right side of our equation thus far. So great. Now that we've arrived to this point, we've arrived to 12 plus 12p is equal to 21. And basically, now what we need to do is we need to combine like terms. So just to refresh your memories of what a like term is, a like term basically needs to follow the following criteria. So like terms have to have the same variables and same degrees. So what I mean by this is I'll give you an example. So for example, if you had 2x and x as your two terms here, you can add these. These are like terms as they're both in terms of the variable x. They both contain the variable x in them. If you had 2y and 2x, on the other hand, these are not like terms, as one term contains the variable y and the other term contains the variable x. So therefore, they are not like terms, as they do not contain the same variable, are not in the terms of the same variable. In addition, I also mentioned that they have to have the same variable, but they also need to be in terms of the same degree or exponent. So if you had 2x squared and 2x, although that 2x squared and 2x are both in terms of the variable x, these are not considered like terms, as they do not contain the same degree. As you can see, 2x squared contains a degree or exponent on the x of 2, and 2x contains the exponent of 1 on the x. So this is not, these are not like terms, as they do not have the same degree on them. And now that we've established that, just keep in mind that like terms do need to have the same variable attached to them as well as the same degree. So now, as you can see, we've arrived to 12 plus 12p equals 21. And essentially what we're trying to do, our goal with solving these kinds of problems is to essentially find out the value of our variable. So in this case, the value of the variable is p. So we're just trying to figure out what the value of p is. And in order to do that, we need to isolate for p. So in order to do that, we need to get p by itself, and we can only do that by combining like terms. So combining like terms, looking at the left side, we have 12 plus 12p. So these are not like terms. We cannot add or subtract these, as there is a 12, which is the constant and has no variable attached to it, but we have a 12p also, which has a variable of p attached to it. So these are not like terms. However, if you look at the right side of this equation, you have a 21. 21 is a constant and so is 12. So you can combine 12 and 21. So we can combine like terms that way. So the way to do this is basically what I'm going to do is I am going to subtract 12 on both sides to get rid of it on the left side. And in order to combine it with the 21, we want to add it to the right side. So I'm going to get rid of it on the left side and bring it here to the right side so I can combine like terms. So I'm just going to write over here 12 minus 12 plus 12p is equal to 21 minus 12. So I'm just going to quickly explain what I did here. So essentially, as I mentioned before, we want to isolate for our variable p, and in order to do that, we need to combine like terms. So what I did here is subtract 12 from both sides, because as you could see, the original 12 on the left side was a positive 12. So in order to get rid of something, you need to perform the opposite operation on it in order to get rid of it. So we had a positive 12. So in order to get rid of that 12 on the left side, we had to subtract 12 on the left side, which is what I have done here. I've subtracted 12 on the left side. But, however, you cannot just subtract or add something on one side and not do it to the other side, as we need the equations to be balanced. So, what I have also done is I've subtracted 12 on the left side, but I have also done the exact same thing. I have also subtracted 12 on the right side in order to help the equations be balanced and also to combine like terms. So in the next step, as you can see, 12 minus 12 is just 0, so they cancel out. So on the left side, we just have 12p is equal to 21 minus 12, because I have subtracted 12 from both sides, and 21 minus 12 is just 9. So we have 12p is equal to 9. So great, now that we've come to this point, as I mentioned previously, we want to isolate for our variable p. So as you can see, there is a 12p on the left side. P is not completely on its own, as there is 12, which is a coefficient of p. 12 is multiplying with p, which is preventing p from being isolated by itself. So as you can see, the operation of multiplication here is being conducted with 12 and p. So 12 and p are being multiplied. So in order to get rid of the 12, which is on the p, as we want p to be isolated, we need to perform the opposite operation of the number, which is either multiplying or dividing, could be whatever, but we need to perform the opposite operation in order to isolate it. So we have 12, which is multiplying with p. So in order to get rid of that 12, we need to divide by 12. So taking this, 12p over 12, and I am doing this divided by 12, 12p divided by 12, and I am doing this simply to get rid of the 12, which is attached to the p. So we have divided the left side by 12. And we also need to do the same thing we do to the left side to the right side. Keep that in mind. So as we divided the left side by 12, we need to also divide the right side by 12. So 9, taking 9, which is what we have on the right side, and just going to do divided by 12. So basically now we just have 12p over 12 equals 9 over 12. And 12 and 12 cancel out here. We have 12p over 12. We can just cancel out 12 and 12. And on the next side, this just leaves us with p is equal to 9 over 12. Great, so we're almost there and we've almost arrived at our final solution. So as you can see, p is indeed isolated, and we're saying that equals 9 over 12. It is isolated, however, it is not the final solution, as 9 over 12 is not a reduced fraction. It is not in the simplest terms. So we must reduce this fraction. So we can just think of the common multiple of both the common divisor of both the numerator and denominator. We need to think of the common divisor of both the numerator and denominator, which is 3 here in this case. So dividing both numerator and denominator by 3, we have 3 over 4, which is a fully reduced simplified fraction, and therefore this is our final answer. So we have isolated for p, and we figured out that p is equal to 3 over 4. So when you have arrived at this final solution, just a reminder, to verify your answers, what you can do is plug in the value you got for p into the original equation for wherever you see p. So in this case, you'd plug 3 over 4 into here where there is a p, and if both the left side and right side equal and they balance, that means that you have found out the correct value for p. If not, that means you have made an error somewhere in these steps. So just to recap what I have done for this question, basically first I have figured out the LCD, which keep in mind stands for lowest common denominator, and I figured out the LCD, which was 20. After that, I multiplied each term by the LCD, which is 20, and I reduced 20 with each denominator after that, just canceling out the numerator and denominators as we just multiplied each term with 20, so we just canceled out the LCD with the denominators, and we just simplified those further. After that, we arrived to a step where we needed to conduct distributive property, and distributive property is just when you take the term on the outside brackets and you multiply out of the brackets. So you multiply each term inside the brackets with the outside term, and we did that. And then we had to combine like terms. Like terms, keep in mind, both have to have the same degree and same variables, and we just combined those like terms. And then we've arrived to 12p equals 9. We had to isolate for p, so I just divided both sides by 12 in order to isolate for p, and just reduce that fraction further in order to get our final answer, which is p equals 3 over 4 to the question 3 over 5 times 1 plus p is equal to 21 over 20. So great, we've just finished our first question. So moving on to our second question. Moving on to our second question here. Our second question is 45 over 16 plus 3 over 2n equals 7 over 4n minus 19 over 16. So keep in mind, the steps to doing this problem is the exact same as what we did for our very last problem. And basically, our first step, keep in mind, is to find the LCD, or lowest common denominator. So let's take a look at the numbers in our denominator. We have a 16, we have 2, and we have 4. So we need to take a look and we need to figure out the smallest possible multiple of the numbers in the denominator. And in this case, the smallest possible multiple of the numbers in the denominator is 16. So therefore, the LCD is 16. So now we need to multiply each term in this equation by the LCD 16. So keep in mind what separates terms are plus or minus signs. So I'm just going to go ahead and take a look at the left side of the equation, which is 45 over 16 plus 3 over 2n. And we're just going to multiply each term by the LCD 16. So we have a plus sign here separating the terms 45 over 16 and 3 over 2n. So we're just going to be multiplying both of those by 16. And on the right side of our equation, we have 7 over 4n minus 19 over 16, 7 over 4n being first term and 19 over 16 being the second term. And we have 7 over 4n minus 19 over 16 times 16. So as you can see, all I have essentially done is multiplied each term, and what separates terms once again is a plus or minus sign. So I've just multiplied each of those by the LCD. So now what we want to do is, I'm just going to just quickly write this out over here. So basically now we just need to reduce the LCD 16 with each denominator. So basically that just means you're going to take your LCD over here and just divide it with the number in the fraction. It's going to cancel them out. So we have 16 and 16, 16 over 16, which equals 1. They just cancel out. Here we have 16 and 2 here, so 16 over 2 is 8. Cancel out. should be an n here, and these cancel out, and this is 8. So 16 over 2 is 8. Here we have on the right side 7 over 4n times 16. We're going to cancel those out. 16 over 4 is 4. And last but not least, our last term, negative 19 over 16. We multiplied that by 16, so canceling out and reducing 16 with the denominator. We have 16 over 16, which is just simply 1. So now, rewriting this in the next step, just like further simplifying this, we have 45 plus 3 times 8n, which is equal to 7n, times 4 minus 19. All right, so we just basically took what we had reduced with, and we just took our numbers, which we kind of got as quotients, and we just plugged those in and just further simplified them. So now in the next step, we should just further simplify and multiply out what we can. So here we have 45 plus 3 times 8n is 24n, which is equal to 7n times 4. 7n times 4 is 28n, and we're just going to write minus 19 as it is. So now great, we've arrived to this step, and what we need to do now is we need to combine like terms. So keep in mind, as I mentioned previously, like terms are terms which have the same variable and same degree / exponent. So basically, we're going to be combining those. And as you can see on the left side, we have 45 plus 24n. Those are not like terms. And on the right side, we have 28n minus 19. Those are also not like terms. So we're just going to rearrange this, and we're going to combine the like terms so we can isolate for our variable n. So taking a look at this, what I'm going to do first is I'm going to subtract 24n from both sides in order to get rid of it on the left side, and I'm going to combine it with 28n on the right side in order to combine like terms. So let's just do that. So there we go. Essentially, all I have done is I have eliminated 24n on the left side by subtracting it on both sides. Because there was a positive 24n here, in order to eliminate that, you need to subtract 24n on both sides. So I just eliminated it on the left side, and I just brought it to the right side so I can combine it with 28n, because 28n and 24n are like terms. So now just writing it out for the simplifying, we add 24n minus 24n, they'll just cancel out. And we have here 28n minus 24n, that is just 4n. And we had minus 19, which was over here on the right side as well. So great, now that we have this, we need to still simplify further, and by that I mean we still combine some like terms. So we just see on the right side of the equation, we had a 4n minus 19. Those are not like terms, we cannot combine them, so we can take this 19 here and we can combine it with this 45, as 45 and 19 are like terms. So we're just going to do this by simply adding 19 on both sides to get rid of it on the right side. As you can see, it's a minus 19, so it's a negative 19. So we have to perform the opposite operation, which is addition. So we're just going to be adding 19 on both sides. So over here we have 45 plus 19 is equal to 4n minus 19 plus 19. In order to get rid of it on the right side, but we can combine it on the left side, because remember, what you do to the right side have to do to the other side, which is the left side. So now that we have this, we have now we have 45 plus 19 on the left side. 45 plus 19 is 64. So we're just going to write that. And we just have 4n minus 19 plus 19. 19 and 19 will just cancel out. So we have 64 is equal to 4n. All I'm going to do now is I'm just going to rearrange this. So the variable n comes on the left side. And now we have 4n is equal to 64. So we are almost done with this question, but not quite yet, as we still have to isolate for the variable n, keep in mind. So we have a 4, which is multiplying with the n, which is preventing n from being isolated. So in order to get rid of that 4, we need to perform the opposite operation in order to get rid of it. The opposite operation is division, because 4 is being multiplied with n, so we need to divide by 4 on both sides. So just doing that, we have 4n over 4, which is equal to 64 over 4. All right, so we're just trying to isolate for n here by eliminating that 4, which is being multiplied with n. So we just divided both sides by 4, as what you do to one side needs to happen to the other side. So just canceling that out, 4n over 4 is just n, simply n. And on the right side, we have 64 over 4. And we can divide that. It can divide evenly. 64 over 4 is none other than 16. So this is our final answer. N is equal to 16 to the question 45 over 16 plus 3 over 2n equals 7 over 4n minus 19 over 16. So great, this is what we've done, and this is our final solution. And keep in mind, what you can do in order to verify your answer is substitute the value of n, which you have figured out, into wherever you see n in the original equation. And if the both left side and right sides equate, then you know that your value of n, which you have figured out, is correct. If not, I would suggest you check the steps which you have previously done. So great. So I just wanted to say thank you so much for attending. I hope you enjoyed and was able to take away something new and useful in today's session. And just a reminder that this session is indeed recorded and will be posted to our website shortly. And if you're wondering, the website link is pasted in the chat and is also displayed on the screen you are seeing right now. So in addition, just another reminder that the next webinar will be on system of equations with two variables. And just keep in mind that these sessions are free. So if you know anyone who is interested or would benefit from these sessions, feel free to let them know so they can also register for next week's session. So once again, my name is Arya Pruma, and thank you so much for attending this webinar. And I hope to see you next week. Thank you and bye.